The effect, if I apply risk reduction measures, and we will have a look at what those are, and it can be if you remember, or if you've heard about the hierarchy of controls, it includes elimination of hazards, substitutions, engineering design, administrative controls. All of those things we can use, and what we want to do is we want to reduce, for at least initially, the critical few, the 20% of the high-risk hazards that we are dealing with. We want to reduce them to a level that is tolerable. In other words, I want to bring the risks down from this level where I say, if the risk is so high that something severe, if the likelihood is so high that something severe would happen, I have to do something. I have to reduce the likelihood or the consequences down into this tolerable risk for all of these hazards. Remember, it's not incidents. These are hazards that are presenting a risk. I will start with my limited resources on the highest risks first. One of the things that we are going to get from our initial risk assessment and the sorting of the hazards from high risk to low risk is we will be able to identify all the critical hazards, all the very high risk hazards. Any task or any work-related activity that involves one of these critical hazards, one of these high-risk hazards, one of the hazards with this high-risk rating, any one of those tasks we consider a critical task. That means that not only do I identify the 20 or the top minority of my hazards that I'm dealing with, I also link those hazards with the tasks that involve these hazards. That will give me a list of critical tasks. Now, once I have the critical tasks that I've now identified using the knowledge of my initial risk assessment and the breakdown of all my activities and tasks, and I link them, I can now pay special attention to the tasks and the activities that involve these hazards. And that will require modification of the task or the process, elimination of the task or the process, changing the tools and equipment that we use, providing engineering protection, additional training, additional supervision, more regular checking of the activities related to that task. When I identify these hazards that present a very high risk and the tasks that are connected to them, I may have to apply risk-specific assessment tools. Those will include things, and these risk-specific tools focus, and the questions that you ask is much more hazard-specific. It's not the high-level initial risk assessment where I just say, here's the hazard, here are the consequences. I now need to analyze the high-risk hazards to the next level. An example would be hazardous chemical substances exposure. I need to look and I need to find out in which class of hazard does this hazardous chemical belong. Is it flammable? Is it explosive? Is it corrosive? In other words, can it cause damage to steel and skin and whatever? Is it environmentally hazardous? Is it toxic? What happens? I also need to understand how much of that hazardous chemical I can absorb. something that we call toxicity. How toxic is this chemical? What in each of these categories, whether it's explosive, flammable, whatever, how probable is it that this will happen? And if it does happen, how great is the risk? We also need to understand, does it get absorbed, if it's toxic, through our skin, through our inhalation, through our breathing, or through our skin contact? Absorption. That is an example of the kind of questions that we ask when we do hazardous chemical substance risk assessment. When I look at vehicles, I need to consider my traffic management plan. So I need to find out, where does this vehicle drive? What's the road surface like? What other vehicles are driving on that road? What are the chances of that vehicle interacting with something that is larger or smaller? What is the visibility? What time of day do they travel? Are there external things, like you are traveling through a very high crime area? Or are you traveling under very adverse weather conditions? Or how long is this person traveling? Can he be fatigued? So those are the kind of questions that we ask when we do a traffic or a vehicle-specific risk assessment. When we deal with these large vehicles, they look at blind angles, where can people not see, visibility, operations, all that kind of stuff. When we look at lifting, we need to identify, there are lifting plans. We normally limit lifts to train people to about 5 tons, but bigger than that, we normally get a qualified rigger. And what they do before they lift is they do a specific risk of a lifting plan. And that lifting plan looks at the weight, looks at the distance, look at the size of the crane that they require, size of the slings, any objects in the area. So a very specific tool related to lifting kind of incidents. Working at height requires a fall prevention plan, where I need to look at, where are we working, what are the external hazards, what are the surfaces that we work on, what is the potential for me to attach somewhere, what can I do to prevent the fall, how can I arrest the fall should a fall still happen, and then also, how do I rescue a person once he has been arrested during his fall? So that is a specific tool that we use for working at height. When we look at manual operations, and there's also an act that tells us that we need to do that, a law, we need to do ergonomic assessment of manual work that people are doing. The positions that they are working in, the amount of time that they spend in those positions, environmental conditions that affect them, like heat, vibration, noise, illumination. So that is once again a specialized risk assessment technique. Also, when we get to isolating energy, there are specific risk assessments where we need to identify what and how these hazards will hurt us, and then we need to apply very specific methods to release pressure, to prevent chemical spills, to prevent explosions, to prevent pressure releases, mechanical releases, and unplanned events. From our initial risk assessment, we get this risk profile, which shows us which of these hazards are the very high ones. We can identify critical tasks, and we now need to apply these very specific risk assessment tools to analyze and further understand these very high-risk hazards. Here is a list of the kind of specialized risk assessment tools, risk assessment methodologies that we can use. Can be hazardous chemical substance exposure, noise exposure assessments, dust exposure assessments, ergonomic assessments, fire risk analysis and assessment, traffic management plans, lifting and rigging plans, fall prevention plans, confined space identification and management, failure mode and effect analysis when we do design and write procedures, task safety analysis, fatigue management, and in food hygiene we use hazard analysis and critical control point hazard analysis. So very different tools, but that we can only do once we have done the initial risk assessment and we've identified the high risk items. We don't want to spend our effort and our resources on low risk items while we still have high risk items present, high risks. Hierarchy of controls is based on effectiveness. So these are the things that we've spoken about. The best way of removing the risk connected with a hazard is to totally eliminate the hazard. So if you have certain poisons that are lying around in your house, for instance, the best way of making sure that your children don't ingest, they don't take in some of that poison, is to get rid of the old poison and the old pills in the correct fashion, of course. If there are certain tools and equipment that are on our workplaces, in our workplaces or on our work sites that are not needed, and we don't need them anymore and they now present a risk. I'm thinking, for instance, and this is more a domestic issue, people that have old fridges, for instance, in the past used to be a thing, and they used to keep these fridges somewhere in the backyard, and children would go and they would play in the fridge, close the door, they can't open the door again from the inside, and people would then suffocate. It used to be quite a big problem, especially in the old days where fridges still had proper latches. Best way of preventing that kind of incident is you make sure that there are no old fridges or that they cannot close and they cannot be sealed so that a child can get inside and suffocate. So first thing, you eliminate that danger. If you are afraid that snakes are going to be a problem, what you need to do is you remove them from your site. Then you cannot have a snake bite incident. The next most effective item is when you substitute something. So if you have an old concrete mixer, for instance, that's got a lot of exposed parts and components, you need to replace that with another concrete mixture that actually has proper guarding. Or what you do, instead of mixing concrete with a batch plant and stuff on your site, what you do is you buy in ready mix from the nearest town, and they come with a pumper, and they then pump this concrete into the area where you need this, depending on the volume, of course, and the price. Engineering controls, that entails things like, I've touched on the concrete mixer with exposed moving parts, for instance, and what we do now is we redesign the mixture, or we put guarding on there, and we make sure that people cannot get hurt accidentally by that concrete mixer. So things like guarding, protection, things like interlocks, if you open up a door that a machine comes to a grinding halt, all of those things are things like engineering controls. Redesigning the process, making sure that a walkway is smooth, putting handrails on so that people cannot easily go off the walkway in the road by accident and so on. The next kind of controls that we are looking at, those are administrative controls. And that is where we do training, we do supervision, we have signs, signals, alarms, all of those things that basically it normally requires quite a bit of effort to maintain these controls. You need to supervise them, make sure people are using them, you've got to enforce them, and it normally requires some human interaction with the control. If there's an alarm, people need to listen to the alarm. If they have been trained, they need to follow the training. If there's a sign or a signal, they need to read the sign and behave according to the sign. I normally refer to these things as wheelbarrow controls because if there's nobody pushing them, nobody standing behind them all the time, then they stop working. PPE is our last resort because that means I cannot reduce noise, I cannot reduce the risk of people getting hit by falling objects, I cannot reduce radiation, I cannot reduce dust, or it is enormously expensive to do so, and then we apply PPE. PPE is the quick and nasty solution for most items, so that's the thing that we want to use last, because it's the last resort. It means that somehow the amount of resources, the cost of implementing elimination, substitution, engineering controls, that is much more than the risk reduction you can get, which is not true in most cases. We want to do substitution engineering controls long before we get to the admin controls. But that is the full range of controls, that is of control philosophies, control groups that are available to us. If I apply effectively the controls from the groups that I've seen, that means elimination, substitution, engineering controls, whatever, then I should reduce the likelihood and or the severity of the consequence connected to these hazards that used to be very high. And you see what happens now? The risk rating for that hazard comes from a 25 to a 20. It changes from a red, a very high risk, to a medium risk. Also, these items that used to be orange, that used to medium, they are now getting towards the low ones. And also the ones that used to be yellow, they are now green because I've also reduced that risk. And all of this is to bring the risks down to as low as reasonably. How do I measure if my risk controls are effective and if my risk controls are reducing the risks as much as I think they should? In other words, I made plans. After I did the initial risk assessment, I made plans to reduce the risk. I put in place things like checklists, training, I modified the processes, all of those controls that we've already spoken about. How do I know that those things are actually reducing the risk? Well, we have two kinds of checks that we can apply. The first one is a group that we call proactive checks. Proactive checks are all of these things that we do: inspections, behavior audits, checklists, site inspections, management walkarounds, NEMIS reporting. So those are the things, job planning, those are the things that we do before an incident has happened. Reactive, we are measuring the amount of mistakes that we make, we are analyzing them, and then we learn from them. Unfortunately, to learn from mistakes, a mistake first has to happen. So you first need to have an incident or an accident or a substandard condition that then results in the possible consequence that you should have identified, and then you learn from that mistake. Unfortunately, those mistakes can be very costly, can cost people their lives, can cost people their health, can result in people being maimed, losing hands, legs, eyes, getting hearing impaired, losing the ability to hear. So reactive measurement, even though we have to do it and we are learning from it, that is the least effective way of measuring our performance. Proactive safety is all about keeping ahead of the game. You've got these hazards, and these hazards are constantly threatening you and your employees and the goals of the organization. By being proactive, we are predicting what can possibly happen, and what we want to do is we want to act before the hazard actually causes harm. It includes things like inspections, interviews with people in the workplace, audits where we look at how effectively the system is working. We're monitoring performance. In other words, we go to workplaces and we say, how is the job going? What kind of inspections are you doing? Are you attending all the meetings? Are you attending the toolbox talks? How effective are they? If I go to a person, I say, did you have a toolbox talk this morning? And he says, yes. And I ask him, what did you talk about? And he cannot tell me. That is a measurement of the effectiveness of the toolbox talk. And if a guy cannot remember what we spoke about, what's the point? So we then have to go and look why people cannot remember what is discussed in the toolbox talk. And we have to improve that. We monitor behavior. We have management walkabouts. We have safety behavior audits where we interact and we coach. We check our procedures through tools like planned task observations, where we sit down and we actually see this procedure that we've written based on our task safety analysis. Is that a safe procedure? Can we follow it? And is it effective in preventing the incident? And we do things like safety sampling, where we go and we do spot checks on certain things. Reactive safety reactive measurements. Reactive health and safety management is all about dealing with the issues with accidents and incidents when they occur. So the hazard is already causing harm, or it has already caused harm. And the reason why that hazard was allowed to cause harm is because my risk assessment was inadequate. I did not foresee the harm that the hazard might cause. Or it could be that my control measures were inadequate. In other words, I foresaw that the hazard could cause the harm. I implemented controls, but they were not effective. They were either there for window dressing, appearing good, or we didn't consistently apply them, or they were addressing the wrong things. But whatever the cause might be, the hazard control was not effective, and the hazard was able to penetrate our barriers and cause harm. That includes things like near-miss reporting, accident reporting, accident and incident investigation, lost time injury tracking, the number of hours that we are working, first aid cases, occupational health tracking, medical surveys, and all of those things once a person gets sick. What we need to do when we track those things, the big benefit that we can get out of them is that we learn where we were not proactive enough. And then our job is to fix the mistake that we made in the first case. So I need to go back to my risk assessments, and I need to go and see, did I identify the hazard? Did I analyze it properly? Did I predict the consequences properly? Did I put the right controls in place? And then I look at the controls. Did I implement the controls properly? Did people comply? Did I enforce them properly? And if I did not, what will I do in future to make it better? But I've already suffered harm by the time that I learn from my reactive safety measures. For a moment, let's talk about effectiveness, because this relates to reactive measurements. What is effectiveness? Effectiveness is the capability, is the ability to produce the desired result or the ability to produce the desired output. So, if I say that you need to move something from here to there in 3 days and you need to do it with a certain budget, if you can manage to do it, then you are effectively applying your resources to achieve the goal. So effectiveness means that you get done what needs to get done. And when you do something, you have the intended outcome. So if you bake a cake, if you fix a machine, when you're finished with the job, then the product, the cake, or the repaired machine is functional again. It is working the way that you intended it to work when you're finished with this job. A lot of the time, when we identify risks and we do risk reduction through the controls, what people are doing is they are listing controls. They are making inspection lists. They are doing inspections. They are writing procedures. They are doing training. They are providing certain equipment and so on. Lots of things that we can set out and say that this is what we are going to do to control the risks. But when we go and look at practice, or in practice, we find that either these risk controls are not being applied, which means that the risk is not getting reduced, or that the risk reduction method that I put in place is not effective. In other words, people are working unsafely, and then what I'm doing is I'm saying, you just complete this inspection list. People fill in the inspection list, but then they still go and work unsafely. What's the purpose then of this inspection list? I think one of the most commonly known examples is when you normally enter some of these facilities, enter a building, enter a controlled facility, and you write there on the visitor's register. You write your name, your telephone number, and you write it so badly, your handwriting is so bad that nobody can even read that again. And it's the same in the workplace where people are filling in forms and completing checklists, but I can't read what is on that checklist. Also, what we do most of the time is we do these inspections, we do the checklists, but nobody goes afterwards and collects this information and analyzes the information so that we can learn from the defects. I see sometimes that people fill in checklists on vehicles and substandards on vehicles. And then 1 year later, that vehicle still has the same defect or the same damage on it. Now, why am I completing the checklist? Training. We give people training, but the training doesn't focus on the risks. And then people go and they either apply training the wrong way or they don't apply the training at all, and then they get hurt. We have hazardous chemical substances. One of the common things that I say is we take this MSDS, the safety data sheet, and we stick it up somewhere on our notice board. And this whole notice board is then covered with safety data sheets. But the people that need to read that sheet, they don't read it. And when they read it, they don't understand it because it uses chemical terminology that people might not have the knowledge or the skills to understand. So when they work with these chemicals, they still expose themselves to danger. They don't wear the gloves, they don't wear the right PPE, they wear the right PPE, but they take off the PPE at the wrong time, in the wrong way, and so on and so on. So, control Controls can only reduce risks if they are effective. And for controls to be effective, I need to fully understand how the hazard is going to hurt me. Because if I apply a control for window dressing, or I don't address how the hazard is going to cause harm, then I will spend my resources and my effort on risk controls, but the hazard will still get to me. My barriers will not be effective in preventing the harm. So when we look at risk controls, please make sure that they are effective and that they will stop the harm from occurring. This whole process of risk assessment, risk management, implementing controls, checking them, is what we call an iterative process. It's not something that happens once and then it is finished. It continues. It starts here when we look at the context for the project or the activity organization. We then do the initial risk assessment, and we use the risk evaluation matrix to allocate risk ratings based on the likelihood of the event happening and the severity of the event, if the severity of the consequences of the event. We can then take all of these hazards that we've named and analyzed and rated for risk. We can sort them and we will get a risk profile. In that risk profile, we will identify a lot of risks that have got a very high risk rating, and they are the ones that will cause our serious injuries, fatalities. Very likely that they will happen, they will cause harm. There are lots of hazards that we encounter on a daily basis that will have minor consequences and have a low likelihood, or even though they might have a high likelihood of happening, but the severity of those hazards on us, or the consequences on us, will be minor. And we are not going to initially pay a lot of attention to them. We want to take our resources, maximize our return, and what we are going to do is we are going to focus on these high impact resources. We are then might also be doing specialized risk assessment. Remember, that was a general initial risk assessment. We now identify the high risk issues. Based on the high risk issues, we now do specialized risk-based risk analysis, risk assessments on hazardous chemicals and all the fatal risks. Based on what we find here during our analysis, we then say we need to apply our hierarchy of controls. We need to eliminate the hazard. We need to substitute the hazard with something. We need to put engineering measures in place. We need to put administrative controls or PPE. We apply these controls, effective controls, until the risk of these high-risk hazards, until the risk connected with them is as low as a reasonably practicable, or unless it is generally tolerable. We can then refocus our attention on the next level of risks, because what is happening here is that we are reducing, if I apply these controls properly, my risks will be reduced. My risk rating of the hazards will be reduced. I will reduce the likelihood or the severity of the consequences. Once I've worked on the high risk issues and I've got effective controls on them, I don't stop. I then apply the same then to my medium risks. Once again, I apply controls to the medium risks until the medium risks are in the as low as reasonably practicable level. And I continue with this process until all my risks, all my hazards, all the risks connected to those hazards are down to a level that is as low as reasonably possible. In other words, for all of my risks, the high level ones, the medium ones, and the low level risks, I am now reducing the likelihood of incidents connected to that hazard is reduced, or I am reducing the consequence of severity. I then check on a continuous basis through proactive measurements and reactive measurements whether my controls remain effective. If they are not effective, then what will happen is they will come out of the level where they are as low as reasonably practicable, which means I then have to commence the process again. In other words, I need to review my context and my operation and the organization. I need to look at my initial risk assessment because maybe I missed hazards, or I underestimated hazards, or I underestimated the likelihood of them, or the controls that we suggested here were not effective. I will again rank my rating. I will manage them down through specialized risk assessment tools if required, applying the controls, reducing them, and so we go around and around and around. And that is simply the process of risk management. Now, what is the result of applying this process to my organization and my activities? You will firstly have risk controls that are customized to your organization, your activities, and the environment in which you are operating. You will manage, if you do this well, you will manage all your risks and controls. And you will manage only the risks and the controls that are relevant to your organization. So you will not be wasting resources on putting controls and measures and doing things which are not even related to risks which might not be present in your organization or the environment in which you are busy. So you are effectively applying your resources to only spend money on controls that are applicable to your operation and your controls, and hopefully all of them. If you do this properly, then you can use your risk profile and your dedicated risk controls. You can use this to demonstrate to your client that you are managing the hazards that are in your organization and connected to your operation and connected to the area in which you are working. And we will then use those methods to put them into things like method statements. And a method statement is simply a response to the risks where you will tell the client how in this project you are going to address the hazards and the risks associated with them while you are executing the task and delivering the service. And you can also demonstrate to your client that you've got a good health and safety plan. You will also have linked processes. In other words, you will only do things, you will do things in your health and safety management system that collectively achieves a result that makes this work for your organization, rather than doing a lot of inspections, doing a lot of paperwork, doing a lot of training and a lot of audits and stuff, which brings you no benefit. It's probably the biggest thing that we see when we look at people with things like SHE files, or where people don't have health and safety management systems in their organization. They get to another organization, and these organizations then have requirements. You must have this checklist, you must have this checklist, you must have this, you must have this, you must have that. And there can be a huge number of pieces of paper, But what happens is that none of these pieces of paper, one doesn't speak to the other one. You just fill them in and you file the piece of paper, but you don't learn anything from this. You cannot use that information to benefit your organization, to reduce the risk, and to eventually get a return on your investment in health and safety management. If you have processes, if you are doing things in your organization which is not, in terms of health and safety, which is not connected to a risk, and where you are doing something but that process doesn't produce information that you then can use to improve on your next activity, you should not have those processes. You have a choice then. You must either make that process work for you, or you should stop that process. The problem is, if the client requires you to have that process, but you don't make that process work for you, don't produce the output, you're going to spend the money to be able to work for a client, but you will not getting any benefit from that. What is a process? I said that you will have processes that are interlinked to produce the results. Well, a series of actions or steps that you take in order to achieve a particular end. In other words, this whole risk management exercise that we've spoken about, they are different processes: defining the context, doing the initial risk assessment, identifying the risk profiling, the specialized risk assessment techniques, implementing control. Those are all processes, and they are all linked together. If I do the initial risk assessment, I have certain inputs, knowledge and people and observations and the law. I output from the risk assessment process a risk profile. Now, I take the risk profile and I identify the high risks. I then take that output of high risks and I focus the small amount of resources that I have, and I only manage those things until they are as low as reasonably practicable. Then I go back to the process of the risk profile and I select the next level of risks, and I manage them down to as low as reasonably possible by the risk controls. And the risk controls in themselves may also be processes, an inspection process, going to a place, using a checklist, analyzing the results, interpreting the results so that you can say my controls are working or it's not working, and then going back to a process of continuous improvement. So all of these little processes, all of these little activities should be interlinked. If you have a process that is not producing anything, that is not linked into a following process, you need to ask yourself, what is the value of that process? Now, I don't want to overwhelm you, but eventually, if I have enough of these processes, if I take all of these processes that I've already alluded to, and that includes the risk assessment tools and processes, the development of controls, making sure that you've got people and resources to actually execute the tasks safely and so on, the training, the checking and the measurement of performance, and then the corrective action to take you to the next highest level of performance. That actually are just the basic processes of a health and safety management system. And that's what we are aiming for, is we want a set of linked, effective processes that identifies our risks, that helps us to understand those risks, helps us to control the risks so that we don't get surprises and it doesn't negatively affect our operations and our product delivery or our reputation. A process of checking that these controls are actually working, learning from our proactive measurements, learning from our mistakes, and then taking those lessons, applying them again to my risk management plan, my risk assessments, and the controls. And then this thing just goes around and around. And as I go along and I learn, my health and safety performance should improve. I should get less and less surprises, and I should get benefit from the money that I'm investing and the resources that I'm investing. And I am not just spending money in an open pit and I don't really know why, and I don't get benefit from that. So this brings us to the end of risk-based management. So based on the hazards and the risks in your organization, you are using your resources to effectively manage these processes to achieve the desired results. And the desired results in an organization would be to safely run your organization and make money and do whatever the organization sets out to do.